Hi guys, welcome back to another video. So today we're going to solve another MIT integration problem, integration B problem. That is, this time, a a qualifier question from 2020. So we have the integral of 1 over the tangent of x raised to the power of square root of 2020 plus 1 from 0 to pi over 2. Would you like to give it a try? If you would like to do so, please pause the video now. All right, let's get started. So to solve this integral, there's actually a trick that you can utilize here. So looking at the power, you might not really know what to do at first, but there's a neat trick, and it is called the King's rule. The King's rule or the King's property. So this rule is actually a neat usage of u substitution in such a way that it simplifies this integral. And in this case, it actually simplifies quite beautifully. So the King's rule in general states that the integral of f of x from x equals a to x equals b is equal to the integral of f of a plus b minus x when x goes from a to b. Now, in case you're not familiar with this rule, I can actually show a derivation of this. So this rule is actually a substitution where you substitute u as a plus b minus x, which means x is equal to a plus b minus u. Now, because we're doing a u sub here, don't forget that we have to also change dx into du. And in this case here, looking from this part of the equation, we've got du equals minus dx. And also we have to change the integration bounds. If x is equal to b, then u is equal to a. Whereas if x is equal to a, then u is equal to b. Now we substitute this to the left integral, then it becomes, so if we rewrite the left side integral, we've got the integral of b to a, f of a plus b minus x, oh sorry, a plus b minus u. And then remember that dx is equal to minus du. So this is minus, and then there's du. Now, because there's a negative sign here, and to preserve the order of the bounds, we can flip the bounds and then multiply the integrand by its negative, by -1, sorry. So this is integral of f of a plus b minus u du from a to b. So this is the rule that we're going to use to solve this problem. Okay, so that means here we will, oh, by the way, I forgot. This here is the same as if u were x, because these are just integration variables. A bit of a small detail actually, but right, there you go. So what do you have to do here? So usually usages of the King's rule is often denoted as a substitution from x to the sum of the two bounds minus x. Because you can see that here u becomes a plus b minus x. Of course, you can be more rigorous and then like say that, oh, this is actually u, this is pi over 2 minus x. But because we already know what the King's rule states, we can use it. We can simply use it here. So this integral is equal to 1 over tangent of pi over 2 minus x to the power of square root of 2020 plus 1. And don't forget the x. Now, this is actually just tangent of pi over 2 minus x, all raised to the power of square root of 2020. And remember what tangent of pi over 2 is. So this is actually cotangent of x. So our integral becomes 1 over the cotangent of x raised to the power of 2020 plus 1. And remember that cotangent is 1 over tan, 1 over tangent. 1 over tangent. Oops. Like this. And now we can rearrange the denominator. 1 plus tangent of square root 2020 x over tangent of x over 2020 dx. And then we can flip the order of this fraction. So this is equal to tangent over 1 plus tangent. Now notice that because we have established that both this form and this form are the same, so it's going to copy this one just in case it's not clear enough. That means we can actually treat this as I, and this is because they're equal, they should be I too. Now, let's see what happens if we add two i's together. So I plus I is equal to adding the left side here. Now, normally you might want to stick with the left side because, well, naturally you've got two of the same expressions of I. So you might want to repeat this expression, but you can also use the other expression because its value is identical. And now notice that the denominators are equal. So by the linearity of integrals, we can merge these two integrals into one. Tangent of this over the same thing. And notice that this evaluates to just one integral of 1 dx from pi over 2 to 0, or from 0 to pi over 2. And this here is equal to pi over 2. So that means I plus I is equal to 2i. And by that, we get I equals pi over 4. So apparently, the power of square root of 2020 did not even matter. So yeah, this is one of the very few cases where you can use a King's rule. It's kind of somewhat of a standard trick, which honestly I myself have not been practicing all that much, but it's neat that you found a problem like this. Okay, did you get the answer correctly? Let me know in the comment section below, and I'll see you next time. Bye.